This title makes no sense. Why would values make a return? It's called value-oriented programming. Shouldn't it have been about value-oriented programming right from the beginning and be about values from the beginning? But last year I did part 1. It was all about functions. So this year it should be part 2 maybe, but like values, it's all about value-oriented programming. Value should have been part 0 or something. It should have been first. But then return of the value sounds so cool. And, yeah, it should be part 6, but value starts with V, so it should be part 5. And I'm sorry to all you people that love Firefly. I mean, I like Firefly too, but what? What's so fun? All right. Anyhow, what are we talking about? What do I even mean by values? I do not mean ethical values. If you want ethical values, where's Kate? Kate's in here. Yeah, that sounds like a Kate talk. I would go to that talk. It'd be a good talk. But also, it's value-oriented programming. That sounds a lot like a reference to object-oriented programming, maybe. Get it? Reference to, like, you don't get it yet. You'll get it later on in the talk, but it's a reference to object-oriented programming. So, what are objects? C++ thinks pretty much everything's an object. Every variable is an object in C++. Like an int is an object to to Patrice back there, anyone who's in the core of the committee. But we don't usually think of ints as object-oriented, right? So maybe I just mean classes. Maybe not every int in fundamental type's an object, but maybe all classes are objects. I don't know why one of these would be an object and the other one wouldn't be an object. They both seem kind of the same to me. They're kind of equivalent. And depending on how you use them, I don't think either of these are objects in the object-oriented sense. I guess I've thought this for a few years now. So it's more like this, right? The classic type of objects. Have to decide where I'm looking. Notes are over here. I can see better over here. I can see you guys better. Yeah, classic object-oriented, kind of like this. So we should be talking about values, however. I have to check something here, sorry. Should be talking about values since this is about value-oriented programming. And values, well, int. Int is the canonical value type. And I could put more examples there, but that's it. Just our goal is to be like int. But I think this is the same, right? This is either one of these is a value type, and it's all about the oriented part of value-oriented programming. We would like to treat this like a value type. We'd like to treat it the same way we treat an int. But I should probably explain a few things first, like what is the problem we are trying to tackle here? There's no sense. What's the point of this whole thing if we're not trying to, make something better, solve a problem? And the problem, I think, is entanglement. And by entanglement, I mean like spooky action at a distance and non-local reasoning, right? Spooky action at a distance where you change something in code over here and it affects something way over there in another piece of code. And you're like, how did that happen? And in general, the more general way of saying that is just non-local reasoning, right? I want to be able to reason about a piece of code without needing to reason about all the code in the program or about code far away from this piece of code. We don't want to have non-local reasoning. And basically, I think that is the number one problem in all my years of programming. I don't care about much else except for keep your code separate so that you can have local reasoning. Keep your stuff separate. So what does this have to do with objects and values? So objects, I think, have two problems. And one is that they are a nexus of complecting, and the other is a graph of references. And what the heck do I mean by nexus of complecting? Complecting is a word that was revitalized by Rich Hickey, who's the author of Clojure. He did a talk called Simple Made Easy, and he, went to the roots of what does the word simple mean, what does complex mean, And it's all about folding and braiding and interweaving. It's right, like the more tangled something is, the more complex it is. And complecting is the verb for making things entangled, basically. And I have a great talk on complecting made easy. It's just a lightning talk. You should go watch it. Not right now. It's got some, Ben gave me all these ways of how to complect things. I remember, and Ben and Connor. Because they're so good at it. Check out Connor's ADSP podcast. We talk about it. So here's a camera class, and well, maybe I should explain why I'm going to talk about a camera class. I work at Christie. We make projectors. What I do at Christie is it's called projection mapping, right? You put some projectors onto an object and you look at some patterns that come out of the projector. You use cameras to look at it, and then we texture map the real world, right? That is a gray dragon, but now it's a purple and yellow dragon. It's got a red eyeball, and I'm pretty sure it hit the eyeball, pretty dead on. Every pixel's in the right spot because we solve the whole world, figure out where everything is using projectors and cameras. So I might talk about cameras and projectors a bit. Oh yeah, look at that little URL at the bottom. So our camera class, and I should mention, I might show some really bad code, and every place I've ever worked has bad code. It's not like all our code is bad, it's just everyone has bad code. I've worked at Adobe and a bunch of other big important companies or interesting companies or well-known companies, let's say. They all have good and bad code, it's everywhere. And maybe you don't even think this camera class is bad, but I sure do. So what do I even want to say about this? So this class is a nexus of complecting because, for one, it's got everything to do with cameras in it, right? And if you imagine it has all these variables to do with cameras, it also has all the functions to do with cameras. It does everything you can do with a camera. You constantly are adding more functionality to this class and more functions to this class. And as you add more functions, every now and then you add another member variable to this class. And it grows and grows without end. And the thing is, it's like, well, it's all part of the camera object. It's everything related to camera. It is the camera class. And, we think it's one-to-one. That's why, there's one, resolution for every camera, and there's one gain and exposure and stuff like that. So we think it's, why wouldn't you put it all in this one class? Because it's all related to camera in a one-to-one relationship. But it's actually not. There's like, most of these are 1 or 0 to 1, right? We don't always have in base image, we don't always have a pose. The pose is both the position and orientation of the camera in 3D space. Through most of the program, we don't even know where that is. That's our goal of the program, is figure out where is the camera, where is the projector, where's the object. So most of the time we don't know these things. So you have a class that is missing half of, like it's only half a class most of the time throughout the program. And even like gain and exposure, every camera has an exposure, but making it part of the class just causes a race condition. You set the exposure, and then you take a picture. And if another thread sets the exposure and tries to take a picture, you're going to get the wrong exposure at the wrong time, right? So exposure should not be part, even though it's physically part of the camera class, it should have been take picture with this exposure. And it should have, been buried in the camera class, how it manages to do that, whether it needs to grab a lock or something, whatever it needs to do, I don't care. It shouldn't have been part of this class. So, maybe this is just bad code, it's just like, it doesn't have anything to do with object-oriented, but I think somehow it does. It doesn't have to, but inherently object orientation, it's not the object's the problem, it's the object orientation that's the problem. Of you feel this, you're compelled to be like, oh, I have a function that does camera something, so I better put it on the camera class, because that's just how you do object-oriented programming. You find what class to put the function on. And the class gets bigger and bigger and more complex. And classes are made of Velcro, right? You just keep adding stuff. That class just moves around, just gets stuff added to it, and it never goes away. And you're like, where did this come from? And you're like, oh, someone needed that thing, right? There's, some of those, like the reverse mask in the camera, the reverse mask image, that's used in one place. It doesn't even, it should have been a local function, a local member of a function almost, local variable of a function. But what happens is, this is why I call it an nexus of complecting. All these different pieces of camera functionality are now all in the same class, and all the functions are in the same class. And so if you change anything about the camera class, you risk breaking something, right? Even though it's local, it's all just local to the camera class. I mean, you can solve all your problems of like, oh, I want local reasoning. I'll just make one class called app and put everything in it. Then everything will be local to the app, right? Like, camera is not even our biggest class. We have another one called model, which really is everything. It's in all caps model, so that you can yell when you talk about it. Camera is tiny compared to model. But you do need a class that holds the whole world, but it doesn't have to do everything. It should delegate more. So that's why it's I find that objects lead to complecting and Velcro and whatnot. And that's what I'm saying. You get non-local reasoning even though it's a local class. It's, a bunch of functions local to this class. But the class is too big to be called local anymore. I should have had your class is so big, jokes. When it sits around the house, it sits around the house. So what about a graph of references? This is the second problem with objects. And I don't even know what's the current like TV show that's full of, mixed relations and stuff. I don't know. Secession, maybe something. I don't know. I don't watch TV. But I think every program looks like this, basically, right? This is your program. This is your program on objects. This is your program on references. Because we all know like global variables are bad, right? And sharing a pointer is as good or as bad as a global variable, right? And you as soon as you start sharing pointers or references throughout your code, you start building these data structures. If you could call that a data structure, you just build a big tangle of objects or a graph of references and pointers. Sean Parent likes to call this incidental data structures. So you have an object A, and it has something X, and that forms a data structure, right? And then you've got another one, you've got B, and also, maybe holds an X or something like that. And maybe for whatever reason, they share this pointer, right? We didn't have to have two. Wow, how did I get? Wow, I totally messed up the. That's an A and a B and an X, trust me, really it is. Wow, I was just looking at this morning. But... There it is. There, it's back. Yeah, it was a bad refactoring job. They used to be labeled differently, and I tried to relabel them. So this isn't two data structures, right? It is one data structure. You think it's two data structures, but it's one because they're tied together through the shared pointer or reference or whatever you have there. So in your head, you're thinking you have this with the right, everything's the right, correctly labeled. And then A decides, it's like, I would really like a chocolate chip cookie, right? Because who wouldn't like a chocolate chip cookie? And then B decides, I'd like a raisin cookie, right? And then A goes and takes a bite, and it's like, oh my God, raisins. It's not like I hate raisins, but I hate when raisins, what's the word? Camouflage themselves, or like you go to grab a cookie and you're like, oh look, chocolate chip cookie, and then you're like, oh, it's a raisin, and you see there's other chocolate chip cookies there, but now you've grabbed the raisin cookie, and you're like, I gotta eat the raisin cookie. It's just okay, but there's chocolate chip cookies, and it's terrible. I've banned raisins from work, but people still keep bringing them in. You can ask Eric over there knows. So you get what we call spooky action at a distance, right? You thought these were two separate objects. And this is obviously a simple case of like, who wouldn't have known that, this was going to happen in an example with two objects and one pointer. But this happens all the time in code. I actually used to work at BlackBerry when BlackBerry was still doing Java on the front end and like C++ in the back end. I was working on the back end. But all the bugs that people kept handing to me, I traced them back into the Java code, and they were all to do with shared references. It's because everything in Java is like you just naturally share references accidentally almost, right? And it would constantly be like, why did this thing change? And they think it must be the C++ guys on the bottom messing with my objects. And it's like, nah, your objects are all entangled. And it's just the spooky action at a distance happens all the time.
How did this happen? We're smarter than this.
We're smarter than this.
Apparently not.
Apparently not. You guys can't just quote Star Wars from episode 2, 3? All right. Yeah, I didn't call it Revenge of the Values. I called it Return of the Values. But I really think all code looks like this. This happens all the time. So I would like to be smarter than this, but apparently we're not. I also call this the steering wheel problem, right? If I hand you let you borrow my car, it's like, here's the keys to my car, here's my car, off you go. And you're driving down the road and the car turns left. It's like, oh, sorry, I'm also holding the steering wheel. I didn't actually just give you the car and let go of it. And it's like, well, we're both driving the car. Is that a problem? And it's not a problem to the car, right? You turn the steering wheel right, the car goes right. I turn it left, the car goes left. The car object is in a fine state of affairs. But the two other objects who didn't realize they were sharing the car object, they're in trouble, right? But there's nothing wrong with the car object itself. It just has an interface of, turn left, turn right. All right, so objects have a tendency to, that is not, my notes don't match what I want to say. Okay, so you get non-local reasoning, you get spooky action at distance. You get both of those from a graph of references, right? Now it's not just non-local reasoning because the class itself is too big. It's non-local reasoning because your class is connected to all the other classes, or as many. And you have to know everything when you try to look at what your class is doing because of all those connections. And then it's all the more likely you'll get spooky action at a distance. In our code, pretty much every major object has a pointer back to model, which is the main object. So everyone has access to everything. So it's quite terrible. I should stop saying our code's terrible. It's great. We do really awesome things. We really do. You saw the picture. We do amazing things. You can show slides later if you want. But why is this a problem just with objects and not values, right? And, well, because of the ship of Theseus, right? Obviously. So the ship of Theseus, if you don't know, is this was a real ship, and this was they were really trying to. There's just based on reality here, some king's ship, and they were trying to maintain the ship, and over time, and so they're constantly replacing pieces of the ship with new pieces of the ship, and eventually you've replaced every piece of the ship, and it's a whole new ship, or it's the same old ship, like, and that's the question is like. Is this still the same ship? Or it's it's not a single piece of it's the same as the original. And then worse than that, or, I don't know if worse is the right word, but whatever. You can take all those old pieces, and if they weren't too old, because we wanted to keep this ship pristine, so we replaced the pieces really quickly. We take all those old pieces and we build a second ship, right? So now you have two, and like, which one is the ship of Theseus? Right, like the one on the bottom is the original pieces. Isn't it the ship of Theseus? But like the one on the top is until we had enough pieces, that was the ship of Theseus. It was the only one, and now we've got two of it. And the other question is, does it matter? Right? Like I don't care. I just need a ship. I don't care which one. They're the same basically, right? They both get me from A to B. But it's like, hey, I'll meet you at the ship of Theseus. We'll go sailing. It's like, well, now I need to know which one you're talking about, right? So I need to know, like, there is the ship of Theseus. It's one ship. So which one is it? Come on. It's right there. It's the one we called the ship of Theseus. I put a label on it. It's the one on the top. Why is it the one on the top? Literally because I labeled it, right? In C++, it's the memory address, right? It's the one at this memory address. It's been the ship of Theseus from the beginning, and you change that change the values inside that memory address, and it's still the ship of Theseus because it's there, right? The letter A, the A in that, not the letter A, the word A, in that sentence there, an object occupies a region of storage throughout its lifetime. I actually asked the committee, internally the committee, I started asking, is that A mean that it doesn't, you could read this as an object always occupies some region of storage. Well, that means it could move around. But this A means it's always the same unit of storage, the same region of storage, right? The object doesn't go anywhere. That region of storage, the address of the object, is what makes it that object, right? So in C++, we just label everything, right? It's labeled by its address. That's what makes it the ship of Theseus. It's the one at this address in memory. Rich Hickey likes to call this, oh yeah, value of values. I knew there was a talk like that. Calls it PLOP, place-oriented programming, right? You're putting a lot of emphasis on this object in this place in memory because you're treating it as an object and basically not treating it as a value. You should just go watch the talk. It's a good talk. Just don't watch it right now. Just watch it later. It's a really good talk. So again, though, why is this address thing so tangled with objects and not values? Because you can take the address of an int if you want, right? And I'm claiming an int is a value, but you can still take its address, and you could also take an int and make it a global variable. And that kind of, locks in its address, and everyone can reference that int as a global variable. Does that suddenly make it object and object-oriented? To a certain extent, I think it does, right? You've turned that int, instead of just being an int that flows through your function or something like that, you've turned this global variable into, it's that int. It's, that object there. It's an important int, and you can watch it change over time and do stuff with it. And I think that's it's a key part of being an object, right? And part of that is because in C++ at least, and most languages that have object-oriented, polymorphism, lends itself to having pointers, right? It's like I have a circle, it's the classic object, circle derives from shape, has virtual functions. To make all this work in C++, you take the address of your circle, but you use a pointer to shape to get the polymorphism, right? You don't have to do it that way, but that is the way object-oriented is typically done, and you've then just introduced a pointer, a reference, and you've said this memory location is very important, You could get rid of that pointer, or hide that pointer. Get rid of that pointer. Polyvariant doesn't exist. It kind of exists. It exists in Godbolt somewhere, godbolt.org. In Compiler Explorer, there's should ask Matt to just search through his giant database of code. Michael Park and I wrote it, which means he wrote it. He's the guy. He wrote variant for libc++. So I was talking to him about it one day, and so I don't know if it's obvious, but polyvariant is just a variant where the first type in the variant in the type list is the base class of all the types in the variant. And so this variant holds a circle or a triangle or a rectangle, but it automatically exposes through the arrow operator the base interface. So you can treat it as a shape of any kind, but you don't have pointers. It's a value type in the sense that you can just make a copy of that polyvariant and you get the right thing. It copies a rectangle or copies a triangle, whatever it is. And there's no pointers to deal with. So you've avoided exposing a pointer. And you still get polymorphism if you want it. And if you don't have pointers, you're not going to get big arbitrary relations like this, and so you can't build this graph anymore. But also means you can't build this graph anymore, right? You have this graph for a reason. Like relations in your code is kind of important, and now we've just gotten rid of all of them, right? So we'd like to bring some of them back, but we'd like to be able to control them a little better. So obviously someone must hold this list of shapes that we have. And let's say that's a layout class that holds, making a bunch of shapes in a PowerPoint presentation or something. And your layout class holds all your shapes. And you can select a shape and you can do stuff. And basically what you get is this or this, right? You could have, normally you would just have a vector of shaped stars, and they would hold a pointer to a circle, pointer to a rectangle, whatever you want. And in the other case, you've removed all the pointers and you've stuffed everything inside the layout class, and the only pointer you have is hiding inside a vector and it doesn't expose it. And in this case, you can, since you expose these pointers, you can then share these pointers if you want and if you need to. And maybe you want to share these pointers because the UI needs to update when your circle changes from green to purple. You want the UI to reflect that change. So we use Qt, signals and slots, stuff like that. And it all relies on pointers basically to be saying, I'm watching this object, any kind of observer pattern. It's like, I'm watching this object. I want to know when it changes, and you end up using pointers for that. For the layout class, you can still have pointers to the layout class, but you can't have pointers to the things inside. If you want to know that the object changed or something like that, you have to go through and ask the layout class if it changed. Now the layout class in our case, do we have a pointer to the layout class, or is the layout class contained in something bigger yet? I don't know. Maybe the layout class maybe it's actually just a Q object using Qt and stuff. I'd probably make the layout class just simple the way it is now, and then have another object that holds that, and that object is connected to the UI and has, gives out pointers to itself and everything. But you've raised the level. I find that code is often, right? If you look at your code down at the bottom of your functions and everything, you'll find fundamental types, right? You'll find int and string and whatever. And those are very much not very object-oriented. And then as you move up, you end up with objects at some point. I just want to push that up a little higher, right? Like maybe layout needs to be object-y, but shape doesn't. Or maybe in another, you refactor again and layout is not object-y, and the thing above it is where the objects and references and relationships live, right? So that's basically called the law of Demeter, right? And the law of Demeter basically says your code shouldn't go foo, arrow, bar, arrow, thing, arrow, arrow, arrow. I want to dig in through this type, through there to get at the thing, because you just shouldn't expose all those pointers, right? Instead, if you want to talk to the selected shape, you have to go through the layout class to talk to the selected shape, because layout owns the selected shape.
Fear leads to anger. Anger leads to hate. Hate leads to suffering.
Yeah. So we all know what he said, right? State leads to objects. Objects leads to references. References leads to sharing. Sharing leads to entanglement, and entanglement leads to suffering, right? Yeah. So let's talk about values. It's really hard to tell, right? Is it the ship or is it just a ship? It's, you're just looking at it, and I don't know if it's the right ship or not. And, we go back to this question of, do you care which ship it is, right? If we're talking about relations like meet me at the ship of Theseus, you do need to know. But if you're just like, hey, I need a ship to take my friends out sailing on the weekend, then are these two ships equivalent, right? And maybe, well, the top one probably lasts longer because it's got all the new pieces, but the bottom one is like, it might be a collectible because it's the original, right? But maybe I don't care about either of those things. I just care if I can get my friends in the ship and it smoothly sails the 7 seas, right? And maybe the color, it's red. They're both red, What parts of this thing, what's the criteria for equality? What tells me whether these things are equal or not, right? And basically it comes down to like 3 things. What's important to the user? What's important to the creator, and not creator of ships, but the creator of your class, the author of your class, and also not important to like some deity or something. Just important to the author of the class. And what is the essence of shipness, right? Maybe it is just transport my friends and sails smoothly and things like that. That's what I care about with the ship. Hopefully, all 3 of these points are the same answers, right? As the author of the class, you might be like, oh, this is the most important things about this class, and this is what equality means. And then all your users use it differently, right? And it should be, you would think it's an easy question of like, it's my class, I just wrote it, I know what equality means. But even on the committee, constantly people bring proposals to the library group on the committee, and I ask, what does equality do with this class? And we don't know. Like we just argue about it for a couple of years. Span is one of them, right? Span does not have equality because we couldn't decide. Yeah. I have people who are mad at me that it doesn't have equality, but it's contentious, that one. I have good friends that are mad at me. But the general idea is called substitutability, right? I want to be, for my needs, I can substitute either of these ships for the function of sailing for the weekend, right? And substitutability mathematically is basically if x equals y if and only if for all functions, f of x equals f of g of, that is totally not right. Wow, that is so not right. F of x equals f of y. Why is there a g in here? For all functions are the same. That's what that says. All right. Wow. All right. Well, you know what I mean. Yeah, that should be F. This is going to show up in a couple of slides. The important part that I was focusing on and didn't even notice that was the all. That's why all has a star on it, right? Address of x equals address of y, right? Like, that's a function. Should that be, x and y are only equal if they have the same address? Well, now we're going back to the idea of identity, right? We don't want identity in this case for equality. We just want the important functions. So we say for all salient functions, whatever that means, and it means the important ones. And it's those 3 categories of important to the user, the person who authored it, and hopefully you get whatever the essence of your class is. So vector, a vector, I'm just afraid I'm going to get some other thing wrong now. If I have a vector of ints and another vector of ints and they have the same ints in it in the same order, we consider those vectors the same, right? We say those vectors are equal. If I add 13 to one of those vectors, but then I remove it again, they're still equal, right? I added a 13, I got rid of the 13, everything's good, nothing's changed. And then I check the capacity of the 2 vectors, right? We don't know for sure, but maybe that v, because we added another item to it, its capacity might have increased. Probably not in this case, but it could have increased. And so in some sense, they're not the same vector anymore. One has more capacity than the other. And maybe for you, in some case, that's important. But typically, that's not important. We don't consider capacity to be a salient property of the vector class. And why isn't it salient? Because users typically don't care. Biggest reason, CppNorth said so. He's the author. It's pretty much never wrong. And it's not, and I suspect CppNorth's reasoning is it's not part of the concept of vector that the vector class is trying to model, what we call a Platonic ideal, right? And the ideal is a vector is a A vector is a container of objects in some order, right? That's what a vector is. Everything else about the vector, oh, it's got actually capacity for more items, or it's here in memory, or it's there in memory, or a bunch of other things. Those aren't part of the concept of what a vector is representing. So they're not part of equality. Speaking of Stepanov and addresses, let's talk about regular, right? Regular is a concept, literally both the C++ concept, word concept, and the, English word concept. And gosh, is the same word because Stepanov is the guy who started doing concepts. So he has a concept called regular, and it's basically, be like int is what regular means. But if we have a class, some object T, like a circle or something, and we want to make a copy of it, so we got A, we got B, they're equal, right? You made a copy. That's what the word copy means. It means they're equal, otherwise it's not a copy. You have a really bad photocopier if it doesn't make copies, right? Yeah, that's exactly what I want to say. So these are equal. And also, not very exciting or interesting, A is equal to A. It's a good unit test in your class. You make one object, is it equal to itself? If you can't get that right, probably I've seen that happen. That's just, what's that called? Reflexive property of equality. All right, so now we add a C and we make a copy of B again. And not only is B and C equal, but all three of them are equal, right? Because it's transitive equality. That's good, that makes sense. But then we change A. A is no longer a purple circle, it's a yellow ellipse. And what do we get? Well, pretty obvious. B and C are still equal, but A doesn't equal B or C, right? It's a pretty simple concept, but it's very vital, right? It's that these are distinct objects, and it goes back to this idea of they're not sharing anything, right? You don't have this, right? It's like you do have chocolate chip cookie, whatever those terrible other cookies are called. Chocolate chip cookie, raisin cookie, let's not even mention them. And if you change one, it doesn't affect the other one, right? You keep your objects separate and distinct. And that's the vital, that and equality are essential to the concept of regular. And why is this concept even important, right? It's like, one, this is how ints work, but it's how you expect everything to work. It's just the natural programmer state of like, oh, I've got this complicated function. I'll take this object, I'll make it temporary so I can, modify the temporary and not the original. And I'll like refactor some code or just rearrange some code. I'll move this thing out of a loop or do all this stuff. And it's basically, sometimes it's just handmade optimization coding. And you mostly assume that, oh, I made a copy. I made a copy so I don't mess with the original. Someone passes me a const ref to some vector or something, and it's like, oh, I actually need to modify that. Oh, I'll make a copy of the vector. Well, I can make a copy and modify the copy because they're distinct objects, and I don't have to worry about that. And sometimes you'll see code where it makes a copy, does stuff, not realizing that there's actually pieces tied together. Because we just shouldn't do that. Had another thought there. Yeah, just popped in my head there of thinking of like when you do hand optimization of moving code around that you think, just let the compiler do it nowadays, but some stuff the compiler can't figure out. And the compiler is really good at figuring out that it can move ints around and other objects around in fundamental types because it knows what they are. But unless it can inline the whole world, the compiler doesn't know that your foo class, your cookie class or something, it doesn't know that it is distinct from the other cookie class. It doesn't know that it is regular. So it can't do a bunch of optimizations. If we could like add a keyword or attribute to your class and say, look, my class is regular. Treat it the same way you treat an int. Suddenly, compilers could optimize a whole bunch of stuff that they can't see without seeing the whole class and inlining the whole world, which is what they currently try to do.
Do or do not. There is no try.
So what did he say there? He said raisins. Have, you must not. Pretty sure that's what he said. No, he didn't say that. He said copy or copy not. There is no shallow. Basically, right, vector, we know what vector looks like. If you make a copy of a vector, you do not get this, right? You get this. There's the whole concept of shallow copy or shallow this or shallow that just shouldn't exist. Just throw the word away, right? You know, the plus operator does plus, right? It does like the equal operator and the copy constructor, it does copy. Like you making it shallow copy that doesn't do copy is like making plus do subtraction, right? It's just like, hey, I know what copy constructor does. It makes a copy. So shallow should never exist. All right, back to circles. We got a circle here. We got another circle, right? We agree those are equal. There's no trick here. That I really did, you know, to the level of PowerPoint, I made a copy, right? Right, we're good. These are equal. All right, what's the circle class look like? What's inside the circle class? Wow. I like his answer. Well, there's radius. That was the first one, and then you said X and Y. We didn't get. No one said like what function should be there, like draw, things like that, derived from shape. But you mentioned color. I think that's yep. There we go. Color. We'll ignore the functions for now.
I thought about the one without the U.
What's that?
I thought about color without the U, but that's fine.
Oh no, color with a U. Like where are we? Yeah, we're in Canada now. Purposely, I'll sadly admit that in our code we take the U's out because our UI, someone decided doesn't have U's in it. So we wanted to make the code match. So it's kind of sad, but I put it in here. So this seems vaguely reasonable. So why do you think these are equal? They're not in the same place. So anyone want to change their mind on whether these are equal? Is X and Y salient to circle? Seems kind of important, right? It depends. Oh, that's a great answer. This is if everyone. I should do a talk on how to like rise up to be a senior or whatever. I'm like principal something now or whatever it is. Someone, you know, my co-op comes to me and says blah blah blah, and I say, it depends. Every time, it's the right answer. And this is, I don't know if everyone realizes this. This is more in C++ than any other language, right? Because in so many other languages, it's just like, oh, just use the visitor pattern or just the blah, blah, blah. Like you just do the way, like do it the way everyone does it in this language, right? And C++ is like, well, wait a second. There's 7 ways I could do this. Which one is the best right now, right? And it always comes down to like trade-offs. And I just find it, I've, you know, used other languages and stuff in, you know, I had to write some Java code once upon a time. And it was hard until I realized, just don't worry about it. Just do it the way everyone does it. And throw away, you know, all your, like, oh, I've got 17 trade-offs. It's like, nah, don't worry about it. You just do it. Which actually means you can write code. Code gets written fairly quickly that way. I just, in the back of my mind, I'm just like, you know. And in C++, we tend to care about everything, right? So what are we going to do with this XY, right? And the thing about XY is it's not an intrinsic property of the circle. XY is an extrinsic property of the circle. Wow, I don't have much time left. You know, all their like playing around with audio doesn't count, right? All right, I should go a little quicker. No, we're good actually. It's a extrinsic property, right? It's a relationship between the circle and the layout, and it's a relationship between the circle and the other objects in the layout, right? So same with an apple, right? And you know, if I had two apples here, you'd be like, well, the X and Y, the position of the apple is important. It's like, no, it's just an apple, right? It's an extrinsic property. And my camera class, right? The pose of where the camera is not part of the camera class. It's just, sure, every camera has a pose, but it's not part of the class. Classes are made of Velcro. We start putting stuff in there. So what are we gonna do with XY? We can remove it from the class. We probably need to put it somewhere, so we don't just remove it. We move it somewhere else, right? And so maybe it goes into the layout or some other class that holds, we can have a layout object. Every layout is full of layout objects, and the X, Y, and whether it's selected and all these other things are there. And then the shape part is the different part of every layout object has a shape, right? And you might even find that the color doesn't belong there anymore, and that, you know, the way the color and the, maybe the edge is a different color, and maybe there's all this whole style to how you color the shape. And the circle part is really just the geometry of the object in the layout, right? And now your circle class has a radius. That, you know what? I don't think that's ever going to be wrong, right? Like it's just, okay, I think we finally got the right circle class, right? And so now you've moved what parts of your code changes, right? This isn't going to change. I mean, it's going to change. You're going to change it to a float someday because you want, but you could get that right from I was going to put float at the beginning, but basically, math doesn't change very often. So I think you're good there. And now you keep your stuff separate, right? And you've moved that stuff out of the circle class because it doesn't belong there. Your other answer is to rename the class. Circular region. A circular region does have an XY, right? And then when I ask, are these two circular regions the same? You'll be like, well, no, obviously not, right? Because they're two different regions in your space. So if you can't name it, you probably don't know what it is. If you don't know what it is, you don't know what it isn't. And if you don't know what it isn't, you don't know what code shouldn't be in it, and so much code shouldn't be in it. I think that's word for word what I said in the committee meeting one day. Because I spend too much time naming things in the committee, but until you name it, I don't know how to answer all the other questions, right? If you tell me this is a circle versus a circle region, I will give you different answers for all the questions that come up. And essence is the essence of naming. Once I know the essence of the class, what this class means, we can name it properly, and then everything else, we can answer the question of what does equality mean, all these other questions. All right, functions. Well, I got a whole talk on functions. That was last year. So quickly go to functions. And the question is, does circle have a draw function? I mean, obviously it does. It's right there. You can see it. It's right there. Oh, should circle have a draw function? Go watch my other talk. The answer is no. We just draw a circle, right? And, pass in the things we need to pass in and some kind of surface, right? How many times have I written a circle drawing code? Like, definitely more than 5. Like, I wrote another one just last week for some reason. That was just for fun mostly, because Bressingham is just awesome. But that changes, right? You change from, writing circles to an image buffer. You change to using good old Windows GDI, and then you switch to something OpenGL, and then you switch to whatever. Like, I've gone through over time, we've changed how we draw so many times. We never change circle, right? So we would like to move the code that, keep the code that changes out of the code that doesn't need to change, separate these pieces. And then also, we can serialize a circle. We can see, does the circle collide with some other shape? And collision is a hard one, right? Does this circle collide with this rectangle? Which class do you put that function on? On the circle class, on the rectangle class? It's like, that's double dispatch. It's a general problem of polymorphism. And it's like, you make it a free function. And talk about how to solve that some other time. So what does go in the circle class? Get radius, set radius, right? Maybe that's it. That's all it's in there, right? And then you can actually ask the question, like, does your circle have any invariance? Why do you even have get and set radius? Why not just have a struct with an int that you can just access? Now, if your circle can't be negative, the radius or stuff like that, then maybe you want a get and set to make sure it never goes negative. Or maybe negative circles radius has a meaning. It's like the circle's inside out, right? It's a purple circle with negative radius. All right. So let's just talk about invariance a bit. Point class is another great example of a class that has no invariance, right? X can be anything, Y can be anything, and they're independent. You can change the X, it doesn't mean Y has to change. There's no relation like, oh, X has to be greater than Y or something like that. If it was like point on the unit circle, then X squared plus Y squared has to equal 1 or something. It's not that class, it's just any point. So there's no reason to have functions on a point class. It's just access the variables, right? Because there's no invariance. And when you have invariance, you want to protect them. Here's a class with invariance. I have a simple graph. Maybe I won't explain how adjacency matrix works, but basically you only need half an adjacency matrix. I will explain how it works slightly. It's a Boolean matrix of 0 is connected to 1 and 1 is connected to 0, so they have a star there. And it's a simple graph where there's no direction. So if one side is connected, the other side, 2 is connected to 3 and 3 is connected to 2, right? So because of that, I only need half the graph, because the graph, or half the matrix, because it's reflexive on itself. And I don't need the middle column because that would be connected to yourself. I just don't allow that. And you can take that and turn that into a vector, right? By ordering the elements. And now I have a vector, yes, a vector bool. That is my adjacency matrix, and it follows this thing. And so the thing that is the invariance is like, how big is the vector based on the dimension of the number of nodes in the graph? And it's this magic formula, which came from 7-year-old Carl Gauss, of like how to add up numbers. And this is the invariant of this class. You can't have dimension not match the size of the vector, but they're not equal. It's not like it's the same number. If it was the same number, I wouldn't need dimension. I would just get the size of the vector. If you actually go from the size of the vector back to what is the dimension, you're going to do a square root and stuff. So I just store dimension as a separate thing, but I have this invariant that these two must match, right? So I have a bunch of functions to ensure that happens. And what functions do I have on the graph class? I can connect, I can disconnect. Yeah, it's not much use if I can only connect and disconnect, but never ask if they were connected. So I can ask if they're connected, and I can do a node count, right? Which is also useful for when you pass in numbers, you probably don't want to be outside the bounds of my graph, right? So, but what was the purpose of this class at all? The purpose of this class was to do what's this called? Graph coloring. I want this graph, that picture there, you'll notice that red is never connected to another red, green's not connected to a green, and blue's not connected to a blue, right? You've colored the graph so that you don't get the same color connected to itself. And this is good for like a million things, like doing register allocation in a compiler. It's good for parallelizing these things. If these things don't share resources, they're not connected, you can run them at the same time. So that is why I wrote this class. So should I have a solve coloring function inside this class? Because that's the purpose of the class, really. It's like, no, I don't need that to be part of the class. We all know this now. Member functions are a terrible idea. I only need those 4 functions to do a graph coloring problem. So those are called the basis functions, right? This is the minimum set of functions you need on this class to do all the things you need to do. And we're avoiding putting a bunch of stuff in the class because classes are made of Velcro and they're nexus of complecting. Now, I did add some functions to this class, right? I don't want to just be able to disconnect them. Maybe I want to disconnect them all, connect them all. The one that's kind of important is like total connections. If I walk through the graph saying, is 1 connected to 2, is 2 connected to the blah, blah, blahs, that's an n-squared algorithm to figure out how many connections are in the graph. But internally, it's an order n algorithm because I've got a vector of bools. It's just how many of them are turned on, right? So most of these functions that I've added are either extremely convenient or actually way more performant than trying to do it outside the class. But this was what I would like to call the basis functions of this class. here's all the functions you need and a couple of things that would be really handy, but they're all generic. They're not trying to solve a single problem. They're all here to solve any problem you have with a graph, well, a simple graph, non-directional graph. All right, calculating versus doing. So here's my circle class, and someone comes by and says, we need to make the colors that go together. So you make a set color to match function. And this is a complicated function because the idea being like, I've got a purple circle, I want another circle that has a nice color that goes with purple, right? And maybe we convert to HLS space and do all this stuff. And this function, I did my best to write a bad function. Why did you take the colored circle as a thing instead of just taking color? This is, this is easier in HLS space. Okay, yeah, but can you explain why? Like, it's not much of a good comment. Member function on color to convert to HLS. Why is this code up here and not in the switch statement? Kit config, is this like magic? Where did this come from? Is this a singleton? And all you needed from the kit config was this one variable to switch on. This rolls over at, it should be mod 360. Another member variable. And here's the worst part is you do all this work and the last thing you do is actually modify this class, right? Everything else was not modifying the class. So take it out of the class, get rid of some of this else. I left half the bugs in there, but find a matching color doesn't need to be part of the circle class. Setting the color at the very end is part of the circle class. Separate calculating from doing. Doing being the part that actually changes the state of your program. Find matching color is now a pure function that doesn't modify anything. It just takes in some input and gives you an answer. And that becomes very local reasoning. You can look at the find matching color function, even if it's ugly and has a giant switch statement in it, you can be like, okay, I can understand this function on its own. I don't have to understand the whole world. And this happens constantly, all the time. This is our real code. You put up this crazy pattern out of the projector and it's being projected onto a curved surface, and trying to figure out which point in the camera matches which point that came out of the projector and build correspondences between camera and projector. And this function that does this is 200 lines of code and it calls like another 1,000 lines of code. It's actually a pretty complicated problem, but there's hundreds of lines of code, and at the very end, it changes the class. It adds the set of correspondences that it calculated to the detector class or whatever it's called. It's not really called detector, but instead of having a function that does all the work and doesn't modify anything and put the modification outside, right? Because I don't even care if it's still, there's reasons that this was still a member function, but it doesn't have to modify the class. And we found this out as soon as we wanted to try to find correspondences, see what the answer is, and then maybe we'll try again and stuff. And it's like, oh, why are we modifying the class inside this 200-line function when it was only like one line of modification? Just take that out. I see that constantly all the time. All right, last one, move semantics. What's an example of move semantics? Oh, right there, there's an example of the same code. Correspondences are big, right? It's like I've got thousands of correspondences. It's a big vector of points that go to points and some other stuff in there. And I just return it from the function, right? Before move semantics and return value optimization, or guaranteed return value optimization, you wouldn't have done it this way because it would be inefficient. Now you can just return objects, big collections of things, whatever you want to call them, objects or not. You can return them like values. Correspondences is just a value. It's a big giant value. It's, thousands of bytes, at least not that big, but it's bigger than an int for sure. But you can just return it and treat it like a value. And move semantics opens up so much of being able to write code like everything is like an int. And this is, our code, you return vectors now. We never used to return vectors. We had to pass in a vector, you'd fill it in. And it's not that different, but I have an image class in our code base that used to be passed around by pointer because an image is giant, right? Megabytes of an image. You don't want to copy that. But now the image class is move only. You can't copy it, right? I've solved that problem. We also used to leak memory all the time. So the image class is a beautiful thing now. And 9 times out of 10, you don't even realize it's move only. You're either passing it into a function by const ref because you want to like process it, or you're returning it and passing it on to somebody else, and you don't even have to call standard move. Like 95% of the time, you never call standard move on my image class. Everything just works. You just think of it like an int. Point clouds are also giant things we have. We have all these giant things that we can just return because of move semantics now. And int, right? Like everything just works like an int. So objects are important. You know, a button in your UI is very object-y, right? You don't when you pass a button to a function, you don't want to make a copy of the button. You never want to copy a button and just suddenly have 2 buttons in your UI. Projectors and cameras, I would love to be able to just make a new projector, which is, you know, hundreds of thousands of dollars of hardware. I would love to be able to make a new one just by passing it by value into a function. So, oh, now I've got 2 projectors. It's great. No. Projectors and cameras, those are very much object things. And they also have different types of cameras, different types of projectors. So we use all the polymorphic properties of that. They're non-copyable. They change, right? They are something you want to know the state of the button, right? It's not just the value of the button. I want to know the state of this button. It is a thing that I want to change over time. It has a lifetime. I want to observe it. I want to form relationships on some objects and polymorphism, although there's ways to do polymorphism without addresses. Whereas values are like int and string and stuff, copyable, movable. You know, int is not immutable, but the value 17 that's inside the int is immutable, right? Like 17 is always 17. You can count on it. It's a number, you can count on it. It's also timeless, right? It's always 17, but it's ephemeral in the sense of ints come into your code and they come into a function, they leave a function, you make copies of them all the time, and they tend to be temporary things. They just come and go, and you don't care because you don't care about the int, you care about the value inside the int. And they're very much mathy, pure functions. And with that kind of work, you can get local reasoning, right? Because you've just got a function that takes some parameters, returns an answer, doesn't modify anything because it's a pure function. And now you get local reasoning, and it's really easy to test that function, right? Because you just pass in parameters and say, this is the answer I should have got. I can test my graph finding function and you know, don't modify the graph. I just pass a graph. I know what the ideal graph is. Coloring a graph is NP hard. So like, you can't always get the right answer, but you can get a reasonable answer. And over here, this slide is like over 10 years old. I was teaching C++ to Java programmers. So they used to be C++ programmers. They did Java. I wanted to come back to C++. And they were so worried about pointers. And they're like, oh, no, pointers, oh my God. And then I was like, oh, no pointers, right? Java has more pointers than value semantic C++ code, right? Everything in Java is a pointer, a reference. And you can write a whole bunch of C++ code with never seeing a pointer. Okay. Yeah, objects, just, and that. And I'm at -2 minutes. So I think we're done.